Hi, so today we're going to be going over an 820-2936 board that has no green light on the charger, and it also doesn't turn on. So we're going to go and do a couple basic measurements to see where the problem is, where it lies, so that I can get an idea where to start. So let's just open up the schematic for it, and hope that this time I finally learned how to use Open Broadcaster so that the scenes don't change and do stupid things for no reason. Okay, so we're good. Okay, so what I say to do is you should check your power rails to see what's present and what's not present. So I scroll down to the power rail section. And it's also important to open a board view. So you may look at the schematic and go, how do I find that stuff on the board? One of the big misconceptions out there is that everybody who does this for a living is psychic and just knows where it is because we're geniuses. And that's not true. We're just idiots that use software that tell us where the stuff is. And the reason this is important is because a lot of websites will sell you the schematic without selling you the board view, which is just a really shitty thing to do. So if you ever bought a schematic without a board view, you need to find the person that sold you that schematic without a board view and, beat their face and file a PayPal claim. Filing a PayPal claim is probably the more civilized thing to do. So first thing we look for is PP3V42_G3 hot. Yeah, so you should be able to see the camera kind of now. There we go. So you can't see the top of my head, but who cares about the top of my head? We're looking for the multimeter on the board. Top of my head is completely worthless. So we're going to measure for PP3V42 here. We should plug the MagSafe in before we measure for PP3V42. Wouldn't that be fucking smart? Okay. So you plug that in. We have no green light in the charger, but PP3V42 is nothing because we're in resistance mode. By the way, if I was using a cheap multimeter instead of a fluke, that would be dead right now. See, so one dumb move and the fluke pays for itself. 3.42 volts. It's not really focused on it because it's set to facial focus, but you can see it's 3.42 volts. Then we measure for PP/G3 hot at 0 volts. So there we know we have a problem. So we're going to start going through that circuit and looking for what's wrong. So I unplug the charger and I put the multimeter into diode mode so that I can measure for a short to ground on that rail. I'm going to take the red probe of my multimeter and I'm going to put the red probe of my multimeter on ground. And then I'm going to put the black probe of my multimeter on a spot on the board where PP/G3 hot shows up. And this tells me that I don't have a short to ground. A short to ground would be this. 0 voltage drop to ground. That is not a short to ground. So what I'm going to do now is I'm going to look around that circuit and try to get an idea for what looks nasty, what may be nasty, what may measure nasty. But the first things first is to actually look at it because I don't feel like measuring stuff. I'm lazy. And I got a lot of stuff to do. I have a long day ahead of me and I got a lot of things I want to do. And one of them is not staring at a board and measuring stuff all day. So this is the ISL 6259 area. It doesn't look very nice. So what looks funny to you here? Can you tell me what looks funny? So the pins that look funny, I'm going to try to point them out. You tell me if you agree. This looks funny. This looks funny. And also this over here. This does not look very nice. So see how this is a nice shiny side of a resistor? Shiny side of a resistor? Sodomized and fucked side of the resistor. Shiny capacitor over here. Shiny side of the capacitor. Sodomized and skull fucked side of the capacitor. That's no good. So let's try to see what that part of the circuit actually does. And let's try to get an idea of what happened to cause that to look nasty. So the whole idea is not to ask for a story from the customers. Because the thing is, your customers are not going to tell you that, oh, this board had a power spike through PP18V5_SO or something like that. They're just going to say that I spilled shit on it. Or in the case of New York customers and East Village customers, it's going to be, did you spill something on it? No. And then you open it and it's filled with green shit and it's, oh, you mean the orange juice that I spilled on it yesterday? Well, why didn't you say so? And it's like, but anyway, let's move on and look through the circuit to see what that stuff is and what it does. So the points on here that look nasty, let's just zoom in on those and let's see if the software will allow me to. This is that shit software from Windows 3.1 days. So every single time I maximize the window, or I fuck with the window and move it around, I have to reopen the board view because it's made for a Windows 3.1 computer. And we don't get to get better software. We're not actually even supposed to have this stuff because there's a big, that whole fuck you to people who try to fix Apple products is going on. So that pin looked nasty. This one looked nasty. And then let's see, in terms of resistors, this one over here looked nasty. So let's look at the schematic and see what's going on there. I actually clicked the wrong thing. It was R7021 that looked nasty, not C7021. Let's see. So charger A gate, that pin looked nasty. That's going to open this and let the adapter voltage through the machine. And this over here looked nasty. Now, I don't really have a way to measure a pin on the U7000. I could measure its resistance to ground and compare that resistance to ground with another board. But that would require getting another board that works. What I can measure is R7021. This I can measure instantly. So which one I measure first is not really a function of what makes sense to measure first. It's really about what's right in front of me and what I could do instantly to try to rule out my problem, which is R7021. Now that's supposed to be 10 ohms. So when I measure R7021, let's see what I get. I'm going to measure R7021. Can you see it over here? Yeah, you can see it over there. So that whole thing of me dropping the multimeter was all for nothing. Okay, I can move the microscope back a little. There you go. All right, so we're going to measure R7021. $37 kilo ohms, and then up to infinite. 2 kilo ohms, 1.5 kilo ohms. Okay, and let's just measure the one under it for shits and giggles. 700 kilo ohms. Okay, let's talk a little bit about what those do and what they're for and what their purpose is in the circuit and why we care that they look fucked up. This is part of a current sensing circuit. The way this works is that the voltage from the charger is going to come through this shunt resistor. This is a 0.02 ohm resistor. There is virtually no power drop across this resistor because its resistance is very, 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 very low. However, there is going to be a really small voltage drop just because it is a resistor and just because it is resisting power going through it. And that voltage drop is going to be really, really low, something like 0.0001 volts. It's going to be something that's ridiculous and negligible over the course of the circuit. However, one interesting part about this resistor is that the voltage drop across the resistor is going to be proportional to the amount of power, the amount of current that's flowing through the circuit. So the more amperage the circuit is using, the more amperage the system is using, the more the voltage drop is going to be. So what the ISL6259 is doing is it has a resistor going to the top of this resistor, and this other resistor here going to the bottom of this resistor. So it's what the ISL6259 is doing is it's reading the power on the top and the bottom of this resistor. And what it's doing by looking at those two voltages is it's figuring out how much amperage the system is using based on the voltage drop across this resistor, which allows it to see that it's actually charging, which allows it to see that, how much amperage the system is using. So let's say the charger is using 15 amps. It's going to know, oh my God, this charger is only supposed to be for using 5 amps. The charger is probably on fire. I should turn off the system. Whereas if it's only using 1 or 2 amps, it knows that it's fine and can continue. This is called high side current sensing, and it's a basic protection feature, basic thing that's built into most modern circuitry. And because R7021 and R7022 are not what they're supposed to be, it's incredibly fucked up. So what we're going to do is I'm going to replace those two. And I'm also going to replace C7020 over here because that may be fucked up as well. And after replacing all those things, we're going to see if it works. We're going to see if we need to replace the ISL6259 or if the ISL6259 is actually usable. I have a feeling we're going to have to replace the ISL6259 because there are some other areas of it that don't inspire confidence, that don't really look great, and we're going to look at those right now. I just want to make sure that you can see what it is that I'm looking at, and let's just take a look over here and show you what it is that I don't have confidence in. So when I go over to the ISL6259 area, there's also this particular pin that just doesn't really look nice. It doesn't strike me as something that I want to keep on my motherboard. Yeah. See, that's just kind of nasty. It may work, it may not. I'm not sure. Let's get the... Get the microscope looking a little nicer. We're going to replace those two resistors with some new ones. Okay. Turn on the air filter. Don't want to die from inhaling this crap. While I'm waiting for my hot air station to get hot, let's see if I can be impatient and remove those resistors and capacitor using pure solder. This comes back. This is one of those things that I learned how to do back before I could afford a hot air station. So if you don't have the tools that you need to do your job, you'll find yourself coming up with fun ways and creative ways to do your job. I don't like the way that looks, so that can also go in the trash. See what I did there is I didn't test the resistor with the multimeter, I tested the resistor with my mind. I determined that the resistor was bad by looking at it and seeing that it looked like shit. So I got 4 volts. We're making progress. 4 volts is considerably more than 0. But I don't want 4 volts. 4 volts is not good enough for me. I want 12. So now I'm going to make a measurement at another point in the circuit. I want to see that the 16 volts is actually making its way to the buck converter. And this 16 volts is indeed making its way to the buck converter. I still don't got my green light though. Let's see, charger boot. So this is feedback. So this is the chip itself. You have a capacitor for charger boot that is then going to a 0 ohm resistor that is then going back to the chip. Let's see how that measures. Is that going to measure properly or is that going to measure messed up? I'm doing something that many people are going to hate, which is using auto range on the multimeter. I know. I'm a lazy prick. I know. I know. I know. You can make fun of me. It's okay. You can hate. You can hate. 0 ohm. Close enough to 0 ohm. So just for the hell of it, I'm going to wind up replacing, let's see, charger boot, and I'm also going to replace the ISL 6259 and see if that works. So if a 16 volt surge went through that part of the chip, I have a good feeling that the chip itself may have gone bad. The ISL is easily killed. So let's get rid of it and put a new one on there. Also, one important thing that you should have gotten from the video of the class, what's one of the most important things to remember when replacing a QFN package? The most important thing to remember is to remember the orientation of the chip. Unlike some people, we don't want to take our chances. Don't want to take our chances. Before I replace the ISL, let's just replace this one capacitor in the charger boot circuit. See if we get anywhere. Because I see that nasty red probe point over there and I don't like it. Most of the time when you're stuck at 4 volts, that is the problem. Now we're back down to 0.3. Huh. Let's try another. Point 1. Yikes. Sweating here. Am I using a good DCN board? Huh. Let's try replacing the ISL. Maybe since it's a bad chip and I heated it, I messed it up a little bit. One of the things I do is I put the old chip on the desk so that I know the orientation of the new chip that I have to put on. And I keep it there. So it doesn't fly away. Actually, while the solder is still hot, I slam it onto the table. I'm sure my desk is not a fan of me constantly burning it, but sadly for it, it does not have a say in the matter. Again, if I wasn't soldering the chip on sideways, I wouldn't be Louis Rossmann. So let's fix that. If I wasn't ripping things off of the board as I soldered, I wouldn't be Louis Rossmann. Why am I being lazy? Switch to the right tip. Watching me solder must surely make you sick. Makes me sick watching it, I know that much. Nasty, but we can clean that a little later. Okay, we get a green light in the charger. And after we get a green light in the charger, the fan spins. And since the fan spins, at this point, I'm good. And that's that. So what happened is there was a spike on the 16-volt rail. Because of the spike on the 16-volt rail that killed the current sensing resistors, the spike that went to the current sensing resistors killed the ISL 6259, and by replacing all of that, we have a board that works. And that's about it. Just how logic, reason, and just the basic understanding of how this stuff works and what to look for helps make it easy.